In this video, we are going to define expectation. So expectation looks something like this: the sum of probability multiplied with x. And you have to do the sum or do the integral. Integral for the case of continuous one and summation in the case of discrete one. Here's a problem to find expectation of x when you roll a fair die. So expectation of x will be given by x p of x. This summation, because it is a discrete case, while we roll a die. So 1 into probability of 1 plus 2 into probability of 2. You have to do this until you reach 6 into probability of 6. You can find out the value. It will be something like 7 by 2. Let's discuss more about this, the properties associated with it. The first property is when x is a discrete random variable. We're talking about discrete random variables, so summation will be a useful tool here. So while discussing that, if PMF is given by P of x and for any real value function g, we are find expectation of g of x, then f of x will be multiplied with g of x instead of multiplying with x. Correct? Now it is a better time to discuss what happens with continuous random variables. So in case of continuous random variables, you have to find the PDF, or it must be given to you. Then you have to just integrate it by multiplying the probability function with g of x. With these two things, the first property and second property, we can just arrange them together and something like this will look into our hand. Moving ahead, if expectation of ax plus b is to be found out, then it is equivalent to write a into expectation of x plus b. This is an exercise for you to find. Similarly, when you are discussing in two variables case, expectation of x plus y is equal to expectation of x plus expectation of y. This can be proved easily using the definition that we have, that is x into p of x. Now we are going to show this proof. So let's just do it. So if you are told to find expectation of x plus y, this is same as finding x plus y multiplied with probability of x plus y. And you run the summation like this. So this will give you x probability of x plus y plus this summation plus this summation y times probability of x plus y. Since x is the variable here, you can write it as expectation of x. And you can write this thing as expectation of y. Now the right hand side looks familiar and this proof is done. With that, I am ending this course. In some other course, we'll be discussing advanced topic related to it. Thank you.